Hey guys, welcome to my new channel. This is actually my very first video in my entire life. And during this series of video, I'm giving you guys a brief review along with some exercises of the book Differential Equations: An Introduction to Modern Methods and Applications. I'll add the link below the video so that you can actually buy it if you want to. Okay, let's get started. So in the first class, today's class, I'm going to give you a quick review about integration so that we can be well prepared for the future classes. Okay, so integration. I'm sorry about the handwriting. I just don't know how to do it with this trackpad. Okay, so as you all know that there's actually two types of integration. The first one is definite integration. And the second one is indefinite. But both of them are kind of the same since all they need to do are just find the antiderivative of the integrand. So suppose f is the integrand, then we need to find the capital f of x such that the derivative of the capital F of x equals to f of x. So if once we find that, then for the definite integration, we'll have the integral of from a to b of f of x dx equals to capital F of x from a to b equals to f b minus capital F a. And for the indefinite one, we'll have the integral of f of x dx equals to capital F of x plus c, right? And there are some basic techniques that we can use to actually compute an integral. The first one is two identities. The integration of f plus g dx equals to the integral of f dx plus the integral of g dx. The second one is the integral of a constant times a function equals to, we can take the constant out of the integral and have this. So this is the first technique. As for the second one, the second one is some basic integral formulas. So I'll just write them down and hopefully you can remember it. And if you don't, you can always refer to this or any table of integral formulas that you can find online. There's dozens of them. Okay, so the integral of x to the power n equals to increase n by 1 times x to the power n plus 1 and plus a constant c. So always remember this constant c. And also notice that it will only work when n is not equals to 1, to minus 1, sorry. So what will happen if actually the integral of x to the power minus 1 is gonna be ln of the absolute value of x plus a constant c. So these are the tools to get that is useful. So as for the third one, we have the integral of e to the x equals to e to the x plus c. It just remains the same. And also the integral of a constant a to the power x equals to 1 over ln a times e to the x plus c. Okay, the fifth one is some trig integral. Then we have some trig integral. The first is the integral sine of x equals to cosine minus cosine of x plus c, since cosine of x, the derivative of cosine of x equals to minus sine of x. And the integral of cosine of x equals to sine of x plus a constant c. Okay, so the next is the integral of sec of x squared dx equals to sine of x. Oh, sorry, tangent of x plus c. The integral of cosec of x squared dx equals to minus cotangent of x plus c. Also, the integral tangent of x dx equals to ln of sine of x dx. I'm sorry, should okay, so where's the eraser? I don't know. This should be cosine of x plus a constant c, and the integral of cotangent of x dx equals to ln sine of x d plus a constant c. And also the integral of 1 over x squared plus x squared dx equals to arctangent of x plus c. And the integral of 1 over 1 minus x squared dx equals to arcsine of x plus c. Okay, so that's pretty much some basic integral formulas that we use pretty often. So as for the third technique, we are going to introduce integration by substitution. Okay, it has two versions. As for the indefinite integral version, so we have the integral of f of g of x, g prime of x dx equals to the integral of f of g of x d g of x equals to the integral of f omega d omega if we set omega equals to g of x. And as for the definite integral, we have the integral from a to b of f of g of x, g prime of x dx equals to the integral from ga to gb, g of a to g of b, f of g of x dg of x. So again, we set omega equals to g of x, then we will have the integral. Sorry. This is f omega d omega. Okay, so then we come to the last technique that we may need to use, the integration by parts. Again, like the integration by substitution, we also have two versions. The first is indefinite version. If it's an indefinite integral, then we will have the integral of f of x g prime of x dx equals to f of x g of x minus the integral of f prime of x g of x dx. So this sort of switch the derivative. And there's also another kind of notation here. So if you use u dv equals to the uv minus integral of v du. So change the position of u and v. They're kind of the same. We can use u equals to f of x and v equals to g of x, then they're the same. As for the definite integration version, we'll have the integral from a to b of f of x g prime of x dx equals to f of x g of x from a to b minus the integration of from a to b of f prime of x g of x dx. So that's pretty much all the general rules that you want to use in your computation. But besides that, there's a little rule for just for a partial fraction of rational functions. Let me create a circle. Partial fraction of rational functions. So this means we have a expression f of x over g of x, where f of x and g of x are polynomial functions. Polynomials. And we call, so here's just, we call f over g is proper if the degree of f is actually smaller than degree of g. Okay. Okay, so when we encounter a function of this form, there's a method. It not works all the time. It will not work all the time, but yes, it's pretty helpful. We're going to talk about this method later, so for now, I'll just give you a simple introduction of it. So the method can be divided into 3 steps. The first one is to factor g of x. And the second one is to break f over g to several parts. Several simple parts. But how to break it? I'll just tell you how to break it in when g is a quadratic polynomial. So when g is quadratic, suppose g of x equals to a times x plus b times x plus c, then we write f over g equals to a constant a times x plus b plus a constant b over x plus c, and we simplify this expression by finding the common denominator, and then we compute a and b, and then we compute a and b. That's a way how to break it. So the third step is integrated separately. Create parts separately. It's a little bit abstract, so I'm gonna give you guys an example about this case. So this is gonna be example 1. Let's see. Let's use those. Okay. Sorry about that. So we consider integral of x over x squared plus 2 times x minus 3 dx. So first of all, we want to break this rational function into 2 parts. So the first step is to factor the denominator, which is x squared minus 2 plus 2x minus 3, which equals to x minus 1 plus x times x plus 3, right? So the second step is to break it into 2 parts with 2 variables, a and b. And we simplify the left-hand side, which is we find by finding the common denominator. So for this term, it's gonna be x minus 1 times x plus 3 on the top and on the bottom at the same time. So we'll have a times x plus 3. Again, for b, we have b times x minus 1, which equals to x minus 1, x plus 3 of a plus b times x plus 3a minus b. Right. Okay, so we want those, the left-hand side equals to the right-hand side, which means a plus b equals to 1 and 3a minus b equals to 0, right? So this gives us b equals to 3a. Plug it back into the first term, we have 4a equals to 1, and then we have a equals to 1/4, then b equals to 3/4. That's x over x plus, this equals to 1/4 times 1 over x minus 1 plus 3/4 times 1 over x plus 3. Then we integrate it. So the third step is integrated. The integral of this expression here follows by the identity. For 2 identities, we can have this equals to the integral of x minus 1 dx plus the integral of x plus 3 dx. So here we use the integration by substitution, since we have dx equals to dx minus 1 here, and dx equals to dx plus 3 here. We'll have this equals to a quarter times ln the absolute value of x minus 1 plus 3/4 times ln x, the absolute value of x plus 3 plus a constant c. So always remember the constant c. And this is pretty much finished our example, the first example. So I'm gonna give you guys a second example. So example 2. Oh, one more thing that I need to mention is that remember the order that I'm reviewing all of the methods. It's pretty much the order you're thinking of about how to solve an integration when you encounter one. So you first see if there's a constant that you can take out, and then you try to use the basic formulas. And if it doesn't work, then you can use the substitution. And integration by parts is our backup. It's gonna be our backup plan, since it's too complicated. And even if you get a form like this, you can't guarantee that it is solvable. But for this exercise, the integral of ln of x squared over x cubed dx. So I like to rewrite it as this, since it's prettier. So as you can see here, we know the antiderivative of this guy here, but this ln of x squared is just so annoying. So we may want to get rid of this thing, but by doing so, we need to take the derivative, since the derivative of ln of x is kind of simpler. If we want to take the derivative, then we use the differential by parts, integration by parts, I mean, right? Right, so we did not let f of x equals to ln of x squared and g prime of x equals to x to the power of -3, which gives us that g of x equals to minus half x to the power of -2, right? By using the first formula. Oh, as for the first formula, yeah. Okay, sorry about this. Okay, so in this case, we have, by using the integration by parts, we have f of x, g of x, which is gonna be ln square root of x times minus 1/2 x minus 2 minus the integral of f prime of x, g of x. So f prime of x is gonna be, by using the chain rule, 2 times ln of x times 1 over x times g of x, which is minus 1/2 x to the power of -2 dx. So we rewrite the first term as this. There's nothing changed here. And as for here, we have 2 minus sign here, so it's become a plus. And we have 2 and 1/2, which canceled out. So our left is ln of x, x to the power of -3 dx. Right. So you see, from here to here, we actually reduce the power of ln of x from 2 to 1, which is kind of like a successful process. So we can continue doing so, and we have to copy the first term and use the integration by parts on the second term again. So in this case, f of x is just ln of x. So this is f of x, and this is g prime of x. So again, g of x is this thing. So we'll have f of x, g of x is the first term, ln of x minus 2 times x to the power of 2 minus the integral of f prime of x, in this case is this, and g of x, which is minus 1/2 again, times x to the power of minus 2 dx. So this equals to minus 1/2 1 to x squared ln of x squared plus, minus 1/2 x 1 over x squared ln of x. For the last term we have, it is a plus 1/2 here, and we have the integral of x to the power of negative 3, which by the product rule, or from here we can see it is just minus 1/2 times x to the power of negative 2, right? So we copy this again, which is really tedious. Make sure you don't miss a sign or something, or otherwise you have to do this point. Okay, so we have a 1/2 here and a minus 1/2 here, so it's gonna be minus 1/4 times x to the power of negative 2. So yeah, that's it. So much for the second example. I'll let you guys to do another example. I will not be able to give you the result, but the process is kind of similar, and the rules are the ones that we introduced before. So exercise 3 is find the antiderivative of this guy. Arc tangent of x dx. And exercise 4. Which is this one. And finally, exercise 5, which is and you can stop here for a while and try to do those 3 problems. So if you're ready, you can click OK, and I will give you the answers. So the answer for the first one, exercise 3, let's see. It's to find the integral of arctangent of x dx. So it is kind of surprising that there's no such formula in the basic formula table, but it is actually achievable since we don't know the integral of an arctangent of x, but we do know the derivative of it. It's 1 over x squared plus 1, right? So we somehow transform it into the derivative. So by doing so, we need to use the integration by parts again. So in this case, this is gonna be u, and this is gonna be v, right? So we have the integral of u dv is gonna equals to uv minus the integral of v du. In this case, it's gonna be arc tangent of x times x minus the integral of v is just x, and as for du, we have d arctangent of x, which equals to x times arctangent of x minus the integral of x. D arctangent of x is just 1 over 1 plus x squared dx. So equals to x arc tangent of x minus the integral of this. Right. We can adjust the constant on the integral for a while and try to use the substitution method. Minus, if we times the 2 here, then we have our 1/2 in the front. Notice this it will just equals to minus 1/2. So right. We can also add a +1 here. It doesn't really matter since it is a constant and the derivative of a constant is just 0. So we have arc tangent of x minus 1/2. This is ln 1 plus x squared plus a constant c, which is the answer. So as for the fourth exercise, exercise 4, we have this. Well, it looks quite terrifying, but actually it's not. You may think about using the method that we used for break them into several simple parts, but actually that will not really work. But as I told you before, we need to think in order of in identities, basic formulas, integration by substitution, and finally integration by parts, right? So integration by formulas. So when we look at if it can be achieved by using the substitution, we may notice. So here's a notice: d over dx of x cubed minus 3x squared equals to 3x squared minus 6x, which is gonna be 3 times x squared minus 2x, which is happen to be the numerator, right? So we have an adjustment, so we can make a little adjustment about that, about the integral by multiplying a 3 on the top on the numerator. Sorry. And then divide by 3, then we have this. Then this equals to 1/3 times the integral of 1x cubed minus 3 times x squared plus 1 dx cubed minus 3 times x squared plus 1. So we have 1/3 times ln of the absolute value of x cubed minus 3 times x squared plus 1 plus a constant c. Okay, as for the fifth one, what is the fifth? The fifth one, okay. Exercise 5, we have the integral of x squared over x1 plus x squared dx. So as I said before, for most of the cases, if we have a partial, if we have what's the name again? Partial fraction of rational functions, then we want this to be a proper expression, which means that the degree on the top has to be smaller than the degree on the bottom. So the way to achieve this in this case is gonna be rewrite it as this. Right. Then we use the first identity to put them into two parts and deal with them separately. We have this. Then it's gonna be x plus c minus c1 minus this is arctangent of x plus c2, which is gonna be x minus arctangent of x plus a constant c. Okay, that's pretty much everything that I'm going to cover today. So thank you for watching, and I will bring more videos this week. Thank you. Bye.